Hi, welcome to my video on polynomial functions. This is the first video, and in this video I'm going to discuss the definition of a polynomial, the names of the polynomials, and the coefficients of a polynomial. And that's all the things you need to know as we work through this unit on polynomial functions. Definition of a polynomial with one variable. This is only one variable, and the variable we're going to use is, most of the time we write it in terms of x. A, x to the n, plus b, x to the n minus 1, c, x to the n minus 2, d, x to the n minus 3, and so on. Notice we have a, b, c, d. You could have an e and an f, just letters. Notice the exponents are decreasing in order. This is in descending order. And we have a, b, c, d are integers. We're going to have all integers, no fractions, no irrational numbers, no i's, and also the n minus 1, n minus 2, and so on are integers up here. We're not going to have fractions. We're not going to have negatives. That's the definition of the polynomial that we're doing. That will be discussed in the earlier unit when we looked at polynomials 1. Some examples are of polynomials is 2x cubed plus 4x squared minus 6x minus 7. Notice the 2, this is a 3, this is a 2, this is a 1. And notice this is really, if you take this term here, this is a negative 7x to the 0, because that's a 3, 2, 1. This is a 0. But we know that a negative 7x to the 0 is understood to be 1, so we just have what we call negative 7 constant at the end. And right here we have negative 9x squared plus 1. And you notice that there's 0x. There's a 2, 1. This is a constant, so the coefficient here is a 0, so that's why it's missing. Understood to be 0x to the 1, which is not there. I got x to the 4th, x cubed, x squared, x constant, 4, 3, 2, 1. That's a 1, and again that's x to the 0 understood. Notes are in descending order. The degree of a polynomial with one variable, and again the variable we're going to use. So the degree of a polynomial is the highest degree of a term. So when I read this one out, I see that's a 1, and that's a constant, which is x to the 0, so the degree is 1. This is a 3, a 1, and this is x to the 0, so the degree is 3. The degree of this one is a 2, x to the 1 is missing, that's a constant, so the degree is 2. It's the highest degree of any one term. 4, 3, 2, x to the 1 constant, which is 0, so the degree is 4. Now notice this one is not in descending order, so we have to put x to the 5, and then we have no 4, so it's a plus x cubed. We have no x squared, and then we have a plus 7x and a minus 10. That's the descending order with the x to the 4th missing and the x squared missing, so the degree of this polynomial is the highest one is 5. And again, let's put this one in descending order. The highest power exponent is x cubed. Then we have an x squared, then we have 11x and a plus 4. So the degree of that one is a 3. Again, they had to be in descending order, or you look around and say, what's the highest exponent? 5, degree is 5. What's the highest exponent? 3, so the degree is 3. Okay, let's continue. The name and the degree of a polynomial. Let's look at the degree and the name. So if the degree is 0, then the name of the polynomial is called, it's a constant polynomial. And a constant polynomial is just a 4. Or you could have negative 3. It's just, this is understood to be, right here, 4x to the 0. And this one is understood to be negative 3x to the 0. So it's a constant polynomial, just one number. Degree is 0. And we have a degree of 1. We have what we call a linear. It's a linear polynomial, and a linear would be x plus 6, or we could have 2x minus 7, and the degree is 1. Degree is 1 here and 0. Degree is 1 here, and this is 0. A degree of 2 is a quadratic. So remember now, just reviewing all the terms that we practiced or we did previous in the unit on polynomials 1. A quadratic has degree 2, so it's x squared plus 6x minus 1, or we could have x, let's say 3x squared minus 4. As long as it starts with an x squared, then it's quadratic. Degree 3 is cubic. It's a cubic polynomial, and a cubic polynomial starts with a degree 3, so it could be x cubed plus 4x. It could be 5x cubed minus x squared minus x plus 2, as long as it starts with a degree 3. And degree 4 is quartic, Q-U-A-R-T-I-C. Degree 4 starts with an x to the 4, so it could be negative 6 x to the 4 plus x minus 1, as long as it starts with a degree 4. And 7x to the 4 plus x cubed, etc. So as long as it starts with x to the 4. And degree 5 is quintic, Q-U-I-N-T-I-C, and it starts with degree 5. So it's x to the 5 plus 2x to the 4 plus x. Or we could have, let's write a longer one down here, 6x to the 5 plus x to the 4 plus x cubed minus x squared minus x plus 10. So it's quintic, degree 5, the leading term. So hopefully that's explained. Now, as a result, pause your video and see if you can classify each of these polynomials from here to 1 to 8. So, classify each polynomial. The degree is 4. Leading one is 4, so it's a quartic. It's a quartic polynomial. And this is only one term, is constant, is a number, so this is said to be constant. This is a constant polynomial. Constant is a number only. And remember, this is understood to be 9x to the 0. So it's all the rest of the coefficients of all the upper x's is all zeros. And this is degree 2, so this is quadratic. This is degree 5. Degree 5 is quintic. Again, memorize these names. This is degree 1, so this is a linear, a line. This is degree 3, so it's cubic. And you can put this in descending order if you wish, or you can look at this and say, well, the highest degree is 1, 4, 2, 5. This is degree 5, so it's a quintic. But I'm going to put it in descending order just as a little exercise. So this is 10x to the 5 plus 6x to the 4 plus 3x squared plus x. So you have to make sure that you have all your terms. 5, I have 4 terms, 4 terms. Notice I'm moving these around, but I don't change the sign because I'm not moving it across the equal sign. And this one is 2, 4, constant. So it's a 4, so 4 is a quartic. And again, as an exercise, put in descending order, negative 9x to the 4 minus 7x squared plus 2. And it starts with a 4, so it's quartic. Now this one's a little bit different. I decided to throw this in for a second. Simplify and name each. So notice that the highest exponent here is 2. The highest exponent here is 2. So that means when you multiply, you're going to get x to the 4th. So this is a quartic, but I'll multiply it out and show you the simplified form. So x squared times x squared is x to the 4th. X squared times 4 is negative 4x squared. 1 times x squared is x squared. And 1 times negative 4 is negative 4. and we add x to the fourth minus 3x squared minus 4. So we have two binomials. So I did the FOIL. I simplified the middle term. Now, it's in descending order. It's simplified, and it has a degree 4, so it's a quartic. And again, you can tell it's a quartic because the highest, if this binomial is in descending order, and this one is in descending order, then each of these have the highest power in front. This is a 2 and this is a 2, so when you multiply you get a 4. Now simplify this one. What I do, I multiply my two brackets first, and then I multiply by the x after. That's just the way I do it. So I go x times x, I'm doing a FOIL, x times 2, negative 3 times x, negative 3 times 2. I simplify that first because it makes it easier. 2 minus 3 is negative 1. And now I multiply x by each of these terms. So I get an x cubed minus x squared minus 6x. And your degree is 3. So a degree 3, we have a cubic polynomial. Now you could multiply x by, if you wanted to, but you got to be careful. I'm going to multiply x by this one. But when I multiply x by this binomial, I do not multiply it by this one because I can only do two multiplications at the same time. So if I multiply x by x minus 3, I get x can only multiply by this one, this binomial here, not by this one. Now I can multiply this binomial by this one, and I'll get an x cubed plus 2x. First outside. Inside is a negative 3, or sorry, that's x squared times 2 is negative 2x squared. That's a negative 3x squared minus 6x. And simplify it. So notice I have the same answer, and I don't have the same answer, no, because I wrote down a 4 here instead of an x. So when I multiply these three, I multiply with this monomial here, I multiply the ones on the right first, simplify it, and then multiply by the x. So be careful. If you multiply by x, don't multiply x by both of these. As a reminder, if I said multiply 2 times 3 times 7, you would go 2 times 3 is 6 first, and then multiply by 7, which is 42. Or you could go 3 times 7 is 21, and you'll get a 42, your choice. But in polynomials, again, I multiply these two first and then the x after. But as long as you do it right, it doesn't matter how you do it. And let's move on. We have, line up the page correctly, function notation for polynomials with one variable, and the variable is spelled variable, right? The variable of x. So the function notation is like p of x, or it could be an f of x, or it could be a g of x, or it could be an h of x. There's many of them. It doesn't make any difference. Q of x, or r of x. You can keep going. T of x. But as long as it has that function notation. And some examples of that function notation would be p of x is equal to x squared plus x plus 1. So this is a function notation for a polynomial, which is a quadratic. And we do one for a linear. A linear is 2x plus 6. That's a function notation in terms of it's the function of. So notice the p of x and the h of x. Now the two, you can tell which is which. The p of x and the h of x is replacing the value of y. We could also have the f of x is equal to x to the fourth, which is a quartic. Or we could have the q of x is equal to 6x cubed minus x squared. It's a cubic leading term. Or we could have the r of x. There's many. You can just I keep writing them all day. And so notice P of x, H of x, F of x, Q of x, R of x. This is a quintix. This is a cubic. This is a quartix. This is a linear. This is a quadratic. And I'll just do one more, and I'll go the J of x is equal to 7. So that's a constant polynomial, has one number. Let's continue. Notation, the P of x equals ax cubed plus bx squared plus cx plus d. Notice this is a polynomial that's in terms of a cubic. The highest degree is 3, and the constant is d. So P of x equals ax cubed plus bx squared plus cx plus d is a polynomial in terms of x, where the ax squared is what we call, this is the leading term. This is the leading term. And we have, because that's the leading term, the first term, a is the leading coefficient. And as you can see, because it's 2, then this is a polynomial that's said to be cubic. And this is the second term. This is the quadratic term. This is the quadratic term. So if you have a polynomial, then each of the terms can be classified as, even though this is a cubic polynomial, the terms are cubic, which is the leading, quadratic, linear term, and this is this constant term. So each of the terms here can be classified by the names that we've learned. And that means that b is the quadratic coefficient. So b is the quadratic, and I COE. I'll write down COEFF. Okay, just we'll write it all out. Make sure. And CX is, that's the linear term. And hence, C is the linear coefficient, COE. And D is the constant term. Of this cubic, D is the constant term. And as a result, obviously that's the constant term, then D is the constant. A constant term has the constant coefficient. So just to make sure on that and explain it, because I'm going to use the terminology coming up later when we do more videos. So just making sure you understand. For each, fill in the chart. Give the polynomial name and the coefficient name. So this polynomial right here, the name of this polynomial, degree is 2, so it's a quadratic. And the 5 is the leading coefficient. 5 is the leading coefficient. Negative 4 is the linear coefficient. And the 2 is the constant coefficient, or the constant term. And here we have x to the 4 cubed square. Oh, I left out an x there. Let me put that x in there. If not, if I didn't put that x in here, I would have to add these two together to get a 9. That would be no linear terms. That could happen. But let's say I just made a mistake and left off the x. So this one, the name of this polynomial, the highest degree is 4, so this is a quartix. A quartix. Very important to learn these names if you're going to follow us in this unit coming up. And that means that 8 is the leading coefficient. 13 is the cubic coefficient. And negative 7 is the quadratic coefficient. This is the quadratic term, so that's the quadratic coefficient. That's the cubic term, that's the cubic coefficient. And keep going, we have -6. -6 is the linear. And we have a -3 is the constant. So just classifying each just to make sure and showing you what's happening. Now, we have this one, but we don't have it in descending order. So the highest is x cubed, then it's a 9x squared, and plus 4. So the name of this polynomial is x cubed, so that's a cubic. It's a cubic polynomial. And 1 is the leading coefficient. 9 is the quadratic coefficient. Notice 9x squared is the quadratic term. X cubed is the leading term, tells me what the polynomial name is. And 4 is the constant coefficient or the constant term. Constant term, constant coefficient is the same thing as the last term at the end of your polynomial. Okay, let's continue. Now that we've learned all that terminology, let's practice writing some of these down. And again, pause the video and see if you can write each of these out in terms of the polynomial function, or function notation, I should say. Polynomial. Polynomial function notation. So we have a p of x. So there's the p of x. That starts it. P of x equals. So what we do, we look for the leading, because it says cubic. Because it says cubic, that means I'm having an ax cubed. So we have, it starts off with, because it's cubic, it starts off with an x cubed. So the leading coefficient of that first term, which is cubic, is a 4. So the next term is going to be a quadratic. And do I have a quadratic term? Quadratic term with a coefficient of -6. So quadratic is degree 2. The next term is a linear because it's degree 1. So a linear coefficient of 8. So I have a term of 8x. And I have a constant term of a -11. So that's the polynomial that represents this information here. Again, it's a cubic polynomial, and the leading term is 4 on that cubic polynomial. Then we have -6x squared plus 8x minus 11. Number 2, again, pause the video. We have f of x, and it's a quadratic. And a quadratic polynomial is an ax squared. Quadratic is degree 2. So this is an x squared. Now we look for the leading coefficient. The leading coefficient is a 3. So since that's a quadratic, the next term is x squared is an x, but we have no linear term. Now I could write down no linear term, no x, and the constant term is 18. But in math, most times, you will not see the 0x in there. So you just, there it is. So you say to yourself, this is x squared, where's the x? There's no x, so that means there's no linear term. And because there's no x, 0 goes into place because 0 times x is 0. And we have the h of x. And a quartic is ax to the 4th. So this is x to the 4th. And what's the leading term? Well, a is -3. That's the same as saying, because a is the coefficient of the first leading term. And it has a linear term. So it has no cubic term. It has no quadratic term. It has a linear term of 8. So that's like x to the 1. And it has a 0. But just to write that down without all the zeros, that's a 0, that's a 0, plus, oh, that's a 4. See, I almost made a mistake again. X to the 0, sorry, -3x to the 4th, that's a 0, and 8x, and that's a 0. So there is simplified. And we have the p of x again. We have a linear, and a linear term is a to the x. So x, It got a leading coefficient of a -2 and has a constant term of 7. So there it is. Linear is x to the 1. And number 5, we have r to the x is the notation, and we have a quintix, and the quintix is ax to the 5. So we put x to the 5 as the leading, and it says, let's see, the leading coefficient. So let's scratch, as I do them now, I got so much here. The leading coefficient is 13, so let's put the 13 there. Now the next one after that is x to the 4th. That's the quartix. So do I have a quartix? -12. Okay, -12x to the 4. So that one's gone. I'm scratching them out, make sure I use them all. Do I have a cubic term? Cubic coefficient of 6. So that's a +6x cubed. Do I have a quadratic term? Quadratic coefficient of 27. So it's a +27x squared. And do I have a linear term? A linear term of coefficient of 1. So that's 1x squared, which is 1x, not x squared. 1x. Linear is x. So this is 1 understood to be there. Done. And do we have a constant term? Constant term of -4. So there's the polynomial r of x that represents all this information. So that's just getting used to the introduction to polynomials, their name, their degree, etc., and the definition. And if you like my video, which is the first video on the polynomial functions, an important topic, moving on in your math, click on the like button. If you're not a subscriber, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.